Okay, guys, I think we're live. I've got the red banner that says we are. Hey, everyone. Welcome to IoT Happy Hour, episode number 26 by my count.
Wow.
Yes, six months, half a year.
That's half a year. You're right. I didn't think about that. Episode 26, our half a year mark. Wow. All right.
Yeah.
Well, congratulations, John. Congratulations, Mark. 26 episodes.
The people who's watching us
and the viewers. Thank you, viewers, for sticking around for 26 of these. I mean, we have a lot of fun, but I'm surprised that I haven't been told yet. Hey, we got to shut this down. We have a blast doing these. So yeah,
and this
thanks.
week we have more open Balenas than Balena West.
And this week I see it's 2-1 open Balena. John, you are outnumbered this week. We are going to be talking about building a Docker container from scratch. I prepared a demo. I tested it yesterday, but I forgot to say my prayer to the demo gods. So we're going to see what happens. If nothing else, it'll be fun hacking. Yeah, get the GIF ready, just in case things don't go our way.
We need you remember the old little round black exploding bomb, like from the cartoons, with the fuse coming out of it?
Yeah,
we need one of those.
You know who had those all the time was Roadrunner and Wile E. Coyote.
Right.
If you know your American cartoons.
We need exploding.
Yeah. We do need to get one of those. So we are going to, like I say, we're going to try our best. I ran through it yesterday, but hopefully nothing has changed from yesterday to today, and we're able to build this Docker container. It's not overly complex, but you never know, especially when doing things live. So let's do quick intros. It's our usual gang. Mark, you want to say just a quick hello?
Sure. Yeah, this is Mark, developer advocate at Balena. So I help developer communities to start with Balena and to use Balena for the win. I'm based in Europe, by the way, in Barcelona.
Yeah, awesome. Very cool. So it's truly happy hour there as opposed to it's 9 a.m. here. So my happy hour is actually coffee, but that's okay. It'll work. John, you want to say hello?
Sure. John Tonello. I'm technical marketing lead here at Balena, and I do some hacking on things. I'm not a hardware hacker, but I play one on IoT Happy Hour.
Yeah, you do. That's all right. I see I Shot JR needs some Balena swag. Yeah, we do need to mail some out to you.
Sure.
It's actually on my list of things to do, and I just got some new swag in, so I'm restocked. So we could probably make that happen. And let's do our what's on your desk segment. Mark, can you cue up our video of Chris? I don't know where he is today, but we could go virtual.
Let's try.
What's on your desk? What's on your desk?
Don't even need him anymore, quite honestly. We've got virtual Chris now.
It never gets old.
No, it doesn't.
I don't know how that is.
I see a comment. I see Sahaj is watching. I heard earlier he said that he was watching it on the big screen while eating dinner with his family. And I also happen to know that his dad's birthday is coming up. So happy birthday, Sahaj's dad. I think that's a week away, but I'm not entirely sure if we're going to have an episode next week. And
why?
We can take a quick moment to talk about that. I'll cover it right now, but we might need to save a deeper conversation on it in case of technical failure on my part. I'm a little bit worried that my laptop is going to reboot on me, just leaving Mark and John here by themselves. So they may have to dive into this deeper if I vanish from the internet for about 4 to 5 minutes while my laptop reboots on me. But I do have a new one on the way, so we're good. But next week, we are doing what is called Balena Summit. And Balena Summit is where the entire team gets together once a year. Now, in years past, that would mean in one physical location. Balena is a distributed company. We are globally, same word again, distributed around the world, right? So, Mark, how many are we up to? You always seem to have a good, accurate count.
You're always challenging me with this question.
Yeah, 90 or so
Something,
balenistas in all corners of the world. And so, yeah, once a year, everybody gets on an airplane and converges in one spot. Last year, I think the past couple of years actually, were in Barcelona. And it's great to get together, meet people face to face, hack, and share experience and share knowledge, and have some good real life conversations. Now, this year, obviously, things are a little different, so we're going to do it virtually, but the premise is the same. We're all going to be together in a virtual environment and spend our week together collaborating. Not that we don't collaborate on a regular basis anyway, but a more focused time. So we're going to have to figure out whether we hold an IoT happy hour next week, or if what that's going to look like. So we'll keep the community updated.
If there is IoT happy hour, there will be more people for sure.
Yeah, if there is IoT happy hour next week, it might be a big party. So we'll have to see what's on the agenda. If we have internal stuff going on and we can't make it happen, then okay, apologies in advance, and we'll see you in 2 weeks. But it might also be a giant party, so we'll see.
Yeah. And part of the fun of the week is, people hacking on stuff. So there may be an opportunity for us to do a show and tell, which would
a possibility as well.
Which would be nice.
Yeah, we'll keep you guys updated. Hello, humans. Hey, Carlo. And I see Sahaj. Dad says thanks. You're welcome, Dad. All right, so let's get on with it. So we already had virtual Chris, and I see virtual Chris is in the comments.
Yeah, join us, Chris.
What's on your desk?
We got a replay of them. All right, so I'm going to switch my camera real quick. And you remember last week on our episode, we did a preview of ARM Dev Summit, and I opened up this SparkFun kit that, there we go, hold on, switch that. That contained the building blocks for our containers over the air session that we're running there, workshop we're running there, which reminded me then that I have actually a couple of other SparkFun parts that I used on a build last year. So let me hold this up. This is a SparkFun P hat, which contains quick connectors. Uh-oh, my blurry camera. Hold on. Focus. Focus. Blurry is all we're going to get today, I think. Well, let's see.
That's okay.
Yeah, you get the idea.
What are the quick connects?
So the quick connects, as you know, I don't like to solder. So you can buy sensors, SparkFun sensors, with a quick connector, which is just simply a 4-wire with a pin. Again, come on, camera, focus on it. No, not going to happen. No, nope. It loves that pie down there too much. But it's just a little 4-wire plug connector that you plug directly into the sensors. This one here happens to be a lightning sensor, and you can daisy chain them. They run over the I2C bus. This one here is GPS.
Cool.
And then I can hook this right up to this one here, which we're going to make use of today. This one is an environmental combo. This one is a BME 280 and a CCS 811, which is a CO2
wow, that's
and
cool.
particulate detector.
That's
I'm
cool.
not going to use the particulate detector today. I'm just going to use the BME 280 portion of it. But the point is then you can daisy chain them all together, or you can actually just run them straight off. There's multiple headers here on the
And
P
how
hat.
many can you connect here on this P hat?
I am not real sure, to be perfectly honest. We'd have to look that up. If any viewers want to go do some research and drop it into the chat, that would be helpful. I shot JR. You might even know off the top of your head. But so it's pretty cool, right? And then you just attach it straight onto the Pi. And for someone like me, now I've got all my sensors, and I didn't have to solder anything.
Is that a proprietary connector, or is it some standard?
I am not sure. I have only seen SparkFun selling it, but I don't know if they necessarily own or have patented any of the IP. I mean, it's really just 4 wires going into a plug, right? I mean, oh, hey, hold on. It might focus a little bit. You can kind of see it there.
Focusing.
Yeah.
The gods
15.
of the camera focus are helping you.
Yeah. 15 cameras and not one of them focus. It's true. I do have a box of cameras. But anyway, so yeah, these are pretty neat. Super quick, super handy. So I'm going to leave this one attached because we're actually going to make use of it in a moment. But yeah, so just a little show and tell on some SparkFun quick connectors there. And there's actually a lot of sensors. So if you go look on the SparkFun website, there are tons of options to connect to that. So, hey, Otis is in. Welcome, Otis. Sahaj, you call them fats? I don't know. What's the proper?
Why not?
I call them p-hats. The H is capitalized. We need to take a poll. All right, how many viewers do we have? We got 12 at the moment. We're going to need to take a poll. Is it pronounced p-hat or fat?
Saying fat.
Yeah, hold on a minute, Chris. Can we get a tally going?
Yeah, because p-hat doesn't sound quite right.
Yeah, I shot JR say fat.
Fat. Quick also.
Yeah, in Arizona they tell it in a different way.
Yeah, it's an Arizona thing, p-hat. Bruno will know. Bruno, let us know. Is it a p-hat or a fat? Carlos says fat. Chris says fat. Sahaj fat. I shot JR fat. All right, I think I guess I'm outnumbered on this one. All right, let me put my camera back on me. Roni says he's seen Quick also in Adafruit. Okay, so I don't know. I don't think then that SparkFun necessarily owns the IP. I don't know if anyone does. Like I say, I mean, it's just a simple connector, right? But let's put the camera back on me for a moment.
No such thing as a simple connector.
Yeah, I guess you know what?
There's
Fair.
a billion.
Yeah, that's fair. All right. Well, Bruno's with me. A p-hat. Andrew,
I think he was
p-hat. I think we're getting close to even now. So Quick is only I2C. All right. Well, we're going to let I Shot JR do some more research for us. Keep us posted, I Shot JR. Let us know. So getting down to it, like I was saying earlier, I want to do a quick demo of what it takes to actually Balenify an application. In order to Balenify an application, that entails building a Docker container. So these Docker containers are something that we kind of throw around and take for granted quite often. And John, I know you're actually really skilled at crafting these. I'm not as skilled, so I'm going to do a pretty simple one. But it's obviously very, very powerful technology and can be used in all sorts of fashions. But as I showed on that what's on your desk segment, I'm going to use a simple BME 280 today. So John, I'm going to start setting this thing up. You want to provide a little color commentary on what a Docker container is and
Sure.
some of the use cases?
Sure. And I think, if you're new to containers, the biggest hurdle I found was just wrapping my head around the differences between sort of building a pack, deploying an application from a package or a binary and separating out those services into distinct containers. And if you come from the VM world, there's a tendency for folks to be like, oh, it's like a VM. And it can be, but that definition doesn't quite match because a VM still has a lot of overhead. But the simplicity of containers mean that they're sharing kernel resources, but you're only deploying just enough services to do that thing. So if it's Apache or Node or, and you'll see some sensor stuff, Python, for example, you don't need everything like of an OS just to get Python. You just run Python and it picks up everything else it needs from the underlying physical or virtual system. And one of the things too, and this will certainly become apparent as David goes along, containers are easy to replicate. You're right. So once you write a Docker Compose or a Docker file, it's good. You can deploy it, redeploy it, consistently over and over again. And if you've ever tried to deploy something just on an OS, and it doesn't have to be for a Raspberry Pi, and you did all these tweaks and configured all the comp files and did everything else, did you write it down? Maybe you did. You started writing it down. And it's really, you're defining an application as, as code that is amazingly flexible. And one of the key advantages too, I think, over the long term is you can update things and modify things independently. So if you're running Apache and you're running Python, you don't have to update Apache and Python. You can just update one or the other, or you can leave those alone in your script that you're running is the only thing you modify. And those other services remain intact and don't need to change. One thing David will show off too, because he is doing it on Raspberry Pi and on Balena OS, which is a native Docker platform that Balena developed. The layers and pushing that stuff from your workstation or from GitHub or other repo to your device can be much smaller because you're just pushing individual services or even individual layers, what we call deltas and differences to the device. So overall, a great solution, just in general, particularly great for these kind of device deployments. Anything to add, Mark, on that?
Well, let me sneak in real fast.
All right.
Mark, I do want to hear yours as well, but I'm going to sneak in real quick just because I want to show that I actually have two Pis on my desk. This one back here is running Raspbian, the further one with the gold or yellowish heatsink on it. That's running Raspbian. I installed Raspbian on it yesterday and have done nothing else to it except enable SSH. So I'm going to SSH to this thing, to this Pi first back here, and I'll show Raspbian and we'll do a quick install. This one here up front is not even turned on, is not powered, as you can see. So we're going to move to this one in a few minutes for Balena OS, but I just wanted to show that one towards the back is a Raspbian device. Sorry, Mark.
No problem. No, actually, one of the things that I really love from Balena, and I hope that you all agree with me, is that there is no lock-in. I mean, we are introducing to the IoT ecosystem the possibility of bring containers into the IoT. So actually, if you have been on IoT projects, microcontrollers or not, it's usually, I have seen Windows 98 on 2015 needed to have a project, an IoT project up and running. So actually bringing Docker containers into IoT, it's a really good news, because IoT application developers or firmware developers can start using 21st century tools and systems and bring them into the IoT. And anything that runs with Docker containers and on Balena OS, actually, it can run in any operating system that can run Docker. So that means that, everything that we are going to introduce here, it's going to run as well on the Raspbian that David has on the table. So it's not just a lock-in that it's just Balena OS, but it can run in any operating system that accepts Docker. That's a nice part that we are trying to, that we are educating IoT developers with a tool that it's actually not locking in people into Balena OS as probably Microsoft or other. Just to mention one, sometimes it's doing with the technologies to forcing to lock in into those technologies and cannot leave, never can leave them. So that's the really interesting part as well of this technology.
Yeah, the portability, I was just going to add, where, you can develop it on your workstation in a sandbox, and you can, it might be x86 and maybe not with a few tweaks. Push it to anywhere else, and it's going to run and perform exactly the same, which
Absolutely.
is the key. That repeatability, and expandability. I built something not long ago, a mail server running, simple thing, and I was able to expand that and add Rainloop, which is a web-based email client, open source, and just add a stanza to my Docker Compose and add all new capability, and it just works regardless of the platform. And I ran it both on Linux workstation, and I put it on a Raspberry Pi 3, and I had a NUC device that I used, and theoretically, it's obviously you can port them to cloud, public cloud providers. It's the basis of Kubernetes. The list goes on. And from a open source standpoint too, you have GitHub and you have your applications. Everything's right there, and you can read the lines. You can tweak these things and modify them pretty easily without having to know a lot.
Yeah, absolutely. I think it's, but David, what are you doing?
Yeah. Probably awesome.
Like
so
it's
let
the end of the world.
Let me tell you what I was doing.
Speaking of copy.
Speaking of copying and pasting, so what I have here, it's a little bit small, and I have a camera that doesn't like to focus, but attached to this Pi, the one that is running Raspbian, is a little BME 280 standalone sensor that I happen to have. And it's a little finicky. I don't really want to pick it up and touch it because, as you know, I don't solder, and these jumper cables are not quite a perfect fit. But over on my screen share, you can see that. Let me get my screen share. Mark, can you get my screen back? Yeah, there we go.
Sure.
So I found this project here over on the PyPI.org site that makes use of exactly this sensor. And these things are really, really cheap. So here they are on Amazon. If this loads, hang on, there we go. So here's a 3-pack of them that I bought for $14, so less than $5 a piece. And the BME 280,
a lot of money, right?
Yeah, the BME 280 is not the absolute best sensor out there, but it'll get the job done, right, for temperature, humidity, and pressure. Really small, just 4 hookups, power, ground, data, and I forget what, CL, clock. There you go. So scrolling down on here, I can see they show you how to build it from source, but I'm taking the easy route. and you can simply install it with a sudo pip install rpy.bme280. All right, easy enough. Also over on my terminal, I did show real quick that I'm SSH'd into a Raspbian, and it is detecting the I2C device, the BME280, on address 0x76. And then I installed, like I just said a moment ago, that library. Okay, so now I've got the library. They also provide a little snippet of sample code. So let's do a copy paste on that.
That's really cool. Can you send us, can you publish the URL on the chat in a second?
Yeah, let me grab that in just one second. You know what? Go, if you have a look, I might have already set it up as a banner.
No problem. I can search it.
Take a look. So I'll just make a new file. Nano, of course, is the best editor. Everybody knows that.
Oh, come on. Why don't you use VI?
There is no such thing as any other editor that ever needs to be used. Nano is the best.
What is the audience saying? What is the audience using?
It doesn't matter.
VI.
Nano is the best.
Insane, man.
Hey, Max.
Another vote. All right, everybody, come on, audience. Get your votes in. Best editor.
Bye.
There's only one answer, but go ahead.
Yeah.
We can take a vote.
And it's 2 letters, man.
All right. So Nano, I dropped in the Carlo is wrong.
Carlo is absolutely correct.
But all right. So now I've got it. So let's run this thing, huh? Python.
So the steps that you went through here, David, just so you have Raspbian, which is now called Raspberry Pi OS, I think. It's running a full kernel. You don't have a desktop, obviously, but you have the full system running, and it's at least 400 megs. I think the last time I checked on Raspbian.
Yeah.
You installed a couple of things that may not have been native to Raspberry Pi OS. Including, looks like this is using Python 2. So you have pip and things like that. Pip may actually come on Raspbian natively.
It did come pre-installed. I didn't install a single thing. This was a download and burn and power on.
So I'm just going through this sort of grocery list of things that will be replicated later in the container. And sometimes, that's something else that can be difficult to get your head around when you're doing things on a workstation or a Pi and Raspbian or anything like that, that there are steps that are obfuscated that you can't really see, that you're going to have to explicitly define later. So then you did that, and you copied a couple things to get it to talk to the driver, and now you're about to fire it off.
Yeah, and so I fired it off on my first attempt, and I got an error that it couldn't read the device. And that's because, as I mentioned, my jumper wires are not exactly right. So I had to push down a little bit off the jumper to make it have contact and try it again. And once it actually made contact, it absolutely worked and pulled the readings. So we can see that at this particular timestamp, this reading is 24.79 Celsius, pressure's 957, and humidity 43%. So it worked out of the box.
And what it's doing is when you run that command, it's giving you a single output. It's not giving it's not output. Yeah. It's not. There's no time series or anything on there. It's just show me what it is right now.
Yeah.
If you put your if you pinch the sensor with your fingers gently and heat it up, you should be able to change it without getting electrocuted.
I was just going to say I might get electrocuted actually, but look at that.
I didn't tell you to lick your fingers, put them in the socket or anything.
Yeah, well, that's why I said I used this quick hat over here for the most part.
And that alone, now that you've been touching it, it's probably already well over
Yeah, you can see the temperature is increasing. Look at that. So it's working. Okay. So now we built
this
an
is
app.
the classical demo. Yeah. To you can do like this. I don't know how it's called in English.
All
And you get
right.
humidity.
So we have proven that this
humidity
code
is good one.
works. Oh yeah, I'm a pro. You kidding? All right. So
He's got no humidity, Mark. He's in Arizona.
now let's build a container, shall we? So,
Wait. So let's explain again. So you are SSHing this Raspberry Pi.
this Pi right back here. Yep.
Cool.
Now it's time to Balenify this application. So
Awesome. Let's make it happen.
Let's do it. Let's Balenify an app. It's a very simple app, but we've shown it works. It's proven to work. All right. So to do that, we are going to need to first start off, get this out of the way, and I'm going to need that in a moment, but I'm already logged into Balena Cloud. First things first, I need to create an application in here. I suppose I will simply call it BME 280. Simple enough. And I'm going to use a Raspberry Pi 3, but you can see how many different types of devices we support. And I'll leave it on microservices is fine. You could use starter or essentials. The difference there is the number of containers that are supported on the device. I'm only going to make one container, but I'll just leave it on.
What are you going to use? So you're going to use Raspberry Pi 3 with 32-bit container, right?
I did choose 32-bit here, and we're going to actually spend a moment talking about that when I go through the process of flashing the SD card, which will take a few minutes, and powering up, and then pushing the container will take a few minutes as well. So rather than me just staring at you all for a couple of minutes, I thought we would save that conversation until then. So, all right, we have gotten an application created. Now it's time to add a device. It already defaults back to a Pi 3. We are good there. I will put it on development. I don't have an Ethernet cable long enough to reach here, so I will.
That raises a whole host of questions.
Yeah. I'll save them for just a moment.
And you could be
still checking your.
All right, and I'm going to click download. What is happening right now is an OS is being generated through our API. Those Wi-Fi credentials are being injected into an OS image, and it's starting to download. Close that back out. All right, you got a host of questions, you say?
We have some questions. Let me check.
Let's see here.
We have the first question from Sahash. Where's Alan? I need to buzz. Probably you can buzz anyway.
Even if buzz him anyway.
Maybe he will connect.
It'll remind him.
Yeah, absolutely. You can buzz him. All right, so we have gotten the image downloaded. It's decompressing right now. And let's get at you ready.
Yeah, the Alan's buzzer, it's like, if a tree falls in the woods and no one's around to hear it, even though the buzzer's not around and no one's around to hear it, it still buzzes.
Yeah. Hey, David, you know what's happening on my etcher since we had, I think it was the Edge Impulse episode on the IoT Happy Hour. I'm just using drag and drop on the Balena etcher. I'm not clicking flash from file, just drag and drop.
No, flash from file is the correct usage.
Yeah, just like Nano.
Just like Nano. Flash from file is, in fact, the correct usage. Drag and drop
is actually very, if you're like me or any of us, you have a folder that looks like this with a lot of different things.
Like this with all of these different cloud
It can
images.
be very handy just to go, I know this is the one, and I'm dragging and dropping it in.
I just hit. I was trying to move that, and I hit. I was just about to move that, and I clicked. All right, hold on a minute. Well, let me switch my. You know what? We'll switch my camera back, and let's. Bottom there. All right. So hang on a minute. You know what? This is probably better anyway.
Well, and it's worth explaining that this process. I mean, David's going to use his Raspberry Pi 3 as his Docker container host, but you could be doing this on a workstation, and you could be doing it anywhere. And what Balena gives him is a couple things from the provisioning. Doesn't have to connect a keyboard or monitor to that device. Doesn't have to manually set any of that stuff. But as soon as it's up and running, it is a Docker host. And if you're following along and you don't necessarily have a device, all the stages that he goes through in creating the Docker files can be replicated on other platforms.
Yeah. All right. It's flashing right now, and then let me get my screen share back up in 1 second.
Geek till it hurts. That's a great idea. Some contextual menus
Absolutely.
for Flash with that. Sure.
That is a good idea. So while that's going, I thought we could take a moment to talk about the base images. We have, Mark, if you look under the banners, there should be a URL for the base images, and I'll get my screen share back up. If I can.
The Balena lib, you mean? Yeah.
There it is, yes. And if you go to that URL, which I am going to do in a moment when I can figure out how to get this thing turned back on, you'll see that there are over 2,000, in fact, 2,479. Here we go.
Let's just paste the URL on the chat.
Perfect. Man, it was more difficult than I thought it was going to be. All right. Well, you can see my flash completed. So we'll get that out of the way. So you can see we have 2,479 containers pre-created that are in here. What that allows you to do is you can sort of see how these variations work. So here's the up core, happens to be at the top. I suspect it was updated a few seconds ago. So a job just ran that created those. We have some automation in place for it. You can see ASUS Tinkerboard, OpenJDK, Surface Go, Ubuntu Node, Intel NUC, Ubuntu Node. So if we come over here to, we also have a list of them all in our docs. You can see the various iterations. John, I'm going to bring this device up, which will take me a moment. Do you want to talk through real quick the methodology here? You can kind of see also on the base images documentation the way in which the combinations are made, how the naming scheme works while I fiddle with bringing the device online.
Sure. And Mark can chime in too.
Yep.
When you're creating a Docker file, usually you're pointing to some existing image out there, and you might point to, if you, like David said, Ubuntu or even Raspbian, in any number of permutations of those. With Balena, what we've done is we've created images that are more easily dynamically defined. So based on your device type, we can detect that as it's deploying and grab the correct image for your platform. So if different ARM types, or if it's x86, 64, that way. And within each one of those types, so if you're looking at Ubuntu, for example, you have Ubuntu Bionic, but you have pretty much every other permutation as well. And what that means is when you're creating a Docker file, you don't have to create a different Docker file from statement to handle different versions for your architecture. You can just say, my Balena machine name and the distro that you want or the image that you want. And these can be used in a Docker file. They can also be used in a Docker Compose. And there are tagged versions that are very flexible for whatever you're looking to do. And that's tied to the platform support. When David said there's well over 2,000 of these, actually, permutation-wise, it's like 20,000 or something like that. But what it means is you grab those images from this repo, the Balena lib repo, for whatever you're working on, and it will just work right out of the base. So here, Balena lib, Raspberry Pi 3, Python. This is actually the type is a Raspberry Pi 3, and it's doing a Python image. So rather than doing a from statement that might be Python, colon 3.7 or something like that. I forget what the latest 3.74 or something. You'd be using this Balena lib Python, and automatically it's grabbing the one that's correct for RPi 3. If this happened to be an RPi 4, it would grab that. If it was an RPi 0, if it was a Jetson Nano, and Intel NUC, any one of our, there's dozens and dozens of device types. Obviously, there are more device types than there are architectures, but these are largely tuned to and tested across all the device types and architectures.
Yeah. So I can also see in here there's some pretty helpful README here that has how to use the image. Okay, great. So it says create a Docker file in your Python app project, and it has some sample code here to make use of. I can see real quickly, I want to check back. My device has come online. I've got Silent Bird. So my Balena device is now online. It does not have any containers yet. We still need to make that, but I'm looking at the clock and we've got 16 minutes left. So I hope we're gonna make it.
Time is flying.
Yeah, time is flying. But so now we have a pretty good basic understanding of what we need from a container perspective, and it's all laid out for us a little bit here in how to go about it. So I forgot to fire this up earlier. I have a VM running, ready to go, and this is just an Ubuntu VM. Again, I'm going to be using Nano as it is the best editor, but I created just a work directory, pretty simple. So I'm in here and I have, you can see the folder is empty, nothing in it, and a blank notepad as well. So not much going on. It is a clean slate here. Now, what do we need to make use of? We need, as it says, a Docker file. So let's make one of those. So we will do, oops, hang on, come back to here, give it a moment for my slow computer and for my keyboard to wake up. Nano Docker file. We come take a quick glance at this. Again, it says we need from Balena lib / Raspberry Pi 3 -Debian -Python latest. Well, John, you already explained that we can replace that with a variable for the type of machine that we are using, because the Balena Docker Hub is filled, like we saw, with Upboard, ASUS Tinkerboard, some Orange Pis are in there. Bruno, I think you made a call out for an Orange Pi 0. So you just simply need to replace it with a variable for the type of machine that you're going to be using. I had this pre-written just to match what we're showing in our documentation here. So from Balena lib, I replaced Raspberry Pi 3 -Debian -Python with Balena machine name. My work directory is the same. You saw me run this command over in Raspbian, pip install rpi.bme280.
That it's a library that you installed before, right?
The library
on your Raspbian.
Copy everything and command python 280.py. Now that 280.py doesn't exist yet, but we're going to make that next. Okay, so let's save this.
And I believe the file, when you use that wildcard, I believe this has to be a dockerfile.template file to parse it.
Right. You might be.
Well, it works, but we give less priority to Dockerfile than Dockerfile template. So
yeah, there is prioritization.
That can be on the second part. Of Balena-fying.
Part 2. That's what next Friday is going to be. It's going to be part 2 of this.
Yeah. So the next thing we need. I see that my machine is starting to slow down, but we're okay still. Oh boy, yep, I'm getting extra letters.
Yeah.
Oh boy, hang on a minute. Hold on, we might not make it. Hold on. Template, yes. Okay, so we're good. Now I'm actually going to need that snippet one more time.
And I noticed that your Docker file, in addition to, so it's grabbing the image, it's setting a work directory, which is just a place to store and land you when you log in. Then it's copying the contents of your workspace there into the container, which includes this script that you're about to do.
Yep.
And again, if you've never used a Docker file or Docker, moving files, you're not FTPing files from your workstation up to a device. You're scripting it again to tell it to say, hey, grab this file and carry it along and put it in this place. And this is a Python file, right?
Yeah,
David?
this is a Python file right here. I'm just calling it 280. You can name it whatever you want. I'm making one change to it, though, which is the address. On this SparkFun hat that I'm using over here, it enumerates the BME 280 over to address 0x77, whereas the cheapo sensor I had on this one via the jumpers came in at 0x76. So I'm just making one quick edit based on the fact that I'm using the SparkFun hat, but that's in the Python, which is actually a pretty valuable lesson in and of itself that you can modify.
And there are tutorials on, like I used some one-wire sensors and used Balena Sense. And it actually has part of its configuration is something that does detecting on common GPIO pins and that sort of thing. Most of these sensors come with decent instructions, on the web about this is where to look for it. This is how to have your device find it. But otherwise, this is pretty much built in, and since you're running a Debian container, is that what, I've already forgotten.
A Debian base with the Raspbian sources added as well. Okay, so next step is Balena push application name. I named my application earlier in the stream BME 280, and I used caps for that as I just had to double check. You can see it right there, BME 280 in all caps. So let's do a Balena push BME to the application named BME 280.
And it's going to probably ask you to log in.
Yeah. You don't do Balena login?
We're going to find out. I'm a little bit worried that this is where my laptop is going to die on us, actually.
So if you're using
Don't put the technical difficulties up yet. It hasn't died yet. Wait for it to die first.
if you were building this on Docker on your workstation, you would do like a Docker compose up or a Docker build and follow those steps. The Balena push is actually doing a build, and you can now see it's going through the Docker file, and
There's the first
it's
one right there.
retrieving the image from the Balena lib. It's going to copy your file over.
Okay, we
Can't
just
see
saw
what your error.
There's the rpi.bme280 pip install. And copying the files, successfully uploaded images.
So it's taking that image that's built in, it's actually pushing it to the Balena build server, right, where it's going to build it.
And we got.
And then it's going to, from there, pull it down to the Raspberry Pi.
Yep. Okay. So the build now completed in the cloud of that Balena push, as you just mentioned, pushed the contents of my directory up to the cloud builder. I mean, it only pushed 2 files in this case, but these things can get very complex very fast.
You see Charlie Unicorn, so you're golden.
Charlie.
What's the size there? I can't quite make it out.
247.14 megs. That Raspbian OS image, by the way, yesterday decompressed was, I think, a couple of gigs once it was fully, because I used the full one. I did use the desktop installation, which I, probably could have sacrificed. But yeah, it was, I want to say, about 3 gigs. So here we are showing 247.14 megs. Now, let's come back. Nope, not there. Let's come back. Oh, and I see that my device has now discovered a new build, and it is pulling it down. As we have seen from 25 previous episodes on this show, I have slow internet, so this might take a little while.
What do you got, like a 28K modem running there?
No, no. It's 56K. Thank you very much.
No, that's the high end.
That is correct. It uses software compression.
You rebel.
Yeah. So this is going to take a little while here. Let's move this over because we're going to come back to the VM and multitask while it does this. So it's going to pull down my container, start it up, and we are going to see hopefully that same data that we saw on the Raspbian version earlier. While it's doing that, it's blazing fast internet, I'm going to already think about what I could do to improve this container. And as I thought about the fact that this little bit of sample code that we demonstrated earlier only ran once, a container actually has a predefined lifetime. It runs a process and then exits out. That's by design the nature of it. So you have to start thinking about a while loop or if true or some other methodology where an application is running at all times. So, Chris, you like the CPU, temperature, memory, and storage stats on the device page. Yes, we built that as part of our release party. 2 or 3 weeks ago now. So if you ever have 11 hours to kill and you want to watch some live hacking and live coding, go ahead and check that out.
Or you can see the result, which is the top right-hand corner.
Or you can just look at the results of that 11 hours of work, which is over here, the CPU, temperature, memory, and storage meters showing you what's going on. And I seem to be stuck at 37%, so I'm getting a little nervous here.
It's probably
especially knowing-
your Mac coming to a grinding halt.
I think it's the device coming to a grinding halt. We just got another percent. All right. Well, that's okay. Knowing that...
Maybe it's your Safari if you try to refresh.
No, it's not Safari. How dare you? Why would you say such a thing?
David thinks Safari is the best browser.
It is the best browser. Everybody knows that as well.
I will not do another poll. Sorry.
All right. Hold on.
Safari Nano. That's going to be your new moniker.
Safari Nano.
Nano is the best browser?
No, Safari Nano. It's just people will know we're talking about David.
Okay. Where was I? Now, let's come back over here.
A13 Tech, I agree with the ThinkPad.
ThinkPad, get out of here. All right. Hang on for a second here. And
As long as you take Windows out of it.
Good start, yeah. All right, let's open up this Docker file. It's thinking about it. It's thinking about opening a text file consisting of about 6 lines. All right, go ahead, John. You were going to say?
No, I was going to say, so this runs your Python script. What you could do as your final command is point to a bash shell script that said, hey, every 10 seconds, run the script, right? In a loop, like you said. And that, I believe that simple construct would keep the container running because it would be infinite.
Why do you prefer to do it on a bash script and not on the Python code?
You can also do it in the Python. That's correct.
Right. A quick and dirty way, would be to have it cycle over and over. But that would mean he would have to open Nano and learn some Python to do that.
Yeah, that is true. I actually did some research on that, and just because I wanted to be exactly like you said,
and he's using Python 2, so
it's going to be
deprecated in a couple weeks anyway.
Yeah. So actually, let's do something like this. 10 seconds, you say, huh? All right, we can make it happen. 10 seconds. So command while, do Python 280.py, sleep for 10 seconds, done. Now before I do that,
you talk about quick and dirty solution?
That's a quick and dirty solution, but it will work.
That's as dirty as it gets.
Yeah.
Oh, here before you push that though.
Exactly.
Let's wait for this thing.
We're at 96%.
Oh my God! You will need to download again the Delta. No,
Delta.
You can talk about Delta. Right. John.
Yeah. So that one line of code, which is actually the last layer, right, of that container. When David does that in the green room after the show, when he does his Balena push again, it will rebuild, yes, but it will only transfer the difference between his running container and the changed one, which would be pretty minuscule, right? Because it's only going to be changing, I don't know how many bits you added by adding 60 new characters.
90-something%. No,
dude, you need some.
It timed out on me. Come on. Hold on a minute.
Someone streaming Netflix in the other room?
I was just going to say, the kids are on virtual school. Are they taking up all the bandwidth here? Hang on a minute.
Shut down school.
Turn off. What happens?
Meanwhile,
if I
it's good to see the CPU of the Raspberry Pi 3. No? Oops.
Yeah.
No, not anymore.
Hang on a minute. Here we go. I just want to see what happens if I turn off the screen share.
Sahaj is right. Yeah, it could be even worse. So we could even restart.
Yeah.
Yeah. But yeah, deltas make a big difference. And when you do a push, you'll see right before you see Charlie Unicorn, the service, its size, the image size, and then the delta size. And the delta size, depending on where your change is in your Docker file, could be minuscule. I did something the other day. I think I had a 300 meg, 400 meg image, and the delta was like 3 megs because it was. And that's all that's going to get pushed over the air to the device. So you can imagine we've been talking about cellular stuff recently.
Mm-hmm.
That makes a big difference. When you're charged by the megabyte, deltas can be very significant. And actually, we were talking about how you can make your images even smaller. You can change the base OS to maybe Alpine, but you can also put your run command. You can combine run commands and do a number of things to shrink them even smaller. And it's, in fact, we have a install packages when you use a Dockerfile template that is basically a script that will run like apt install, but what it does is it does the apt update, it does the apt install, and then it cleans up after itself. And I found that by just swapping out install packages from the apt commands saved me about 20% of the size of an image that I did once. And a lot of that is because my cleaning up wasn't expert and it wasn't nearly as thorough as the install packages, which is significant. When you're looking at 30 or 40 megs on a 400 meg thing, it's quite the savings in bandwidth. It can equal
that's
dollars
amazing.
and cents.
Yeah.
And one day we will talk about how these affect the cellular connectivity as well.
Yeah. So David, we're about 4 after the hour now. How you making out?
How are you doing?
Not looking good, guys. It's not looking good. I'm gonna try one last time.
The good part is that you're still here. So we were expecting
Yeah, we were thinking that I wasn't gonna even be able to make it.
I'm gonna add the comments here.
Yeah.
The recent post I did that's similar to what David's doing, where I converted a Motion app that was running on Raspberry Pi to a containerized application, and it follows many of the steps that David outlined here today, and details some of those. I haven't done this before, or what are the other things that I need to think about when you're going from a VM or a Pi running Raspbian to running Docker containers. And the nice thing about any of these things is that you can run it anywhere when you're done. When you get it to work, and I'm sure David will if he ever gets internet. But that's a highly portable item, and you can share that with me as a collaborator. He can publish it to GitHub. He can use it anywhere he wants on multiple devices.
I have to say it was not a fair demo, actually, because we didn't see the Raspbian, how you download the Raspbian, enter with the Raspbian on SD card, put it power up a Raspberry Pi with Raspberry Pi 3 with Raspbian. This is what you did with Balena OS. So it was not a fair comparison. And actually, what will be actually the extra points is if we want to run in our Raspberry Pis, John and me, the application that you are doing. If we have Raspbian or if we have Balena OS, right?
Yeah,
Right.
because
Yeah.
all the work starts long before in getting that device up and running with
Exactly.
Raspbian.
Well, so in that scenario, yeah, that gets into the scaling and the fleet management realm, and that's where Balena OS and then the container, and you can push the container to multiple devices, which would not be possible on a Raspbian device. And I have to wonder actually if it's the SD card that is failing me here.
But there are obviously a lot of examples of containerized applications in Balena Labs. If you go to our the Balena.io website, you'll see blog posts about a lot of those projects. But also in the GitHub repo for Balena.io, you'll find any number of cool projects to try, and you'll see documentation from our hardware hackers is very good. So you'll see as you're going through configurations, even if you're new to Docker, you'll see in the file constructs that they've put together how those things work and what's happening under the covers. So you certainly don't have to start from scratch. And I think it helps sometimes to use someone else's app and then deconstruct it and make it your own to rapidly get up and running.
And can you give 5 cents about Balena blocks, John?
I'll let you do Balena blocks, man.
So maybe let's
We need to save that one for Chris. Yeah, need to save that one for Chris. See if he's around next week.
Exactly. We should have Chris again.
We should force him to.
Yeah, virtual Chris is pretty good, but maybe real Chris could talk about Balena blocks next week, especially after Summit week.
Mercury
and Phil, all those guys. Maybe we should corral the hackers, our in-house hardware hackers, to talk about blocks and the mind-blowing capability.
Yeah.
And truly. I don't know if Rahul and Thomas have been on an IoT happy hour, so it would be good to have all the hardware hacker team and make what's on your desk.
Yeah, Thomas has been. It's been a while. I do not know if Rahul has ever...
What's on your desk?
Stuff on my desk. Well, we might have to call it early. I knew we should have said a prayer. I knew it.
We will need to create a prayer.
I knew it. We need a new.
We actually have a little altar.
We sure do. So I flashed a new SD card, hoping that would work, but it hasn't seemed to help. Hang on a minute. Let's switch back over to here just for a moment. Share. Nope, that. Share. Should come back up. I flashed and I got Dark Butterfly now, and he just came online. And let's just see what happens. Dark Butterfly is checking in, realizing that there is a workload waiting, and started to download. Let's just see how it progresses. Because if it does better, then I have to wonder if, yet again, a case of a dying SD card is the culprit. Let's just see if it gets to 37-ish% and dies.
Who created this Giphy?
I don't know where that one came from.
That's mine. Well, you made it a requirement. You made it necessary.
Exactly.
You're pretty quick with your graphics arts work. Let's see what happens.
Well, since he introduced his own lunch is in my desk. Hey, Ronnie, good to see you here, by the way. Ronnie helped me a lot with the basic station LoRa gateway.
Oh, very cool. I saw that where did I see that get tweeted this week? Maybe Hackster? I can't remember. I know I saw it go out somewhere.
An Edge Impulse, yeah.
And Edge Impulse.
Actually, what we made, if you watch the episode of the IoT Happy Hour on the LoRa Basic Station Gateway that we made with Jose from Rack, actually now it's compatible, the 2245 Rack LoRa concentrator that we showed during that demo. Now that repo, it's compatible with this LoRa concentrator and with the 2287 that I was showing last week that I had on my table, this one. So both now are compatible under the same repo of code. And yeah, and Ronnie helped
folks
improve the code
to,
plus Rahul.
So do folks need to update? Let me switch my camera back to me. Do folks need to do anything in particular, or how does that work exactly then?
Actually, we made it work with device variables. Actually, Rahul had a great idea. So we are compiling both versions. And then depending on the device variable that it's called model, and you say rack 2245 or rack 2287, it executes one compilation or the other on the container. So that's a really cool solution.
Nice.
Yeah, that is super cool.
Looks like this, your metrics on the device look a little more favorable. Like it's actually working this time.
Yeah, it might be.
Of course, I just jinxed it, I'm sure.
Yeah, why would you say that? Why?
And I would say that that we are lucky that you are not doing the demo with a Raspberry Pi Zero.
Tomas's favorite device, the Pi Zero.
We should note, though, because this code is portable, you could deploy this to
You absolutely
Pi Zero.
could. Yeah, you absolutely could. All right, this is where we died the first time. It was right at like 96%, 97. Oh, no. All right.
But the activity...
The suspense is killing me.
The activity meter is better this time.
Yeah,
like before, like there was almost no CPU activity, which was probably...
Yeah.
It was doing all reads and writes.
Yep. 100. Okay, hold on a minute.
There.
Cool.
It's firing up.
Whoa, hold on a minute.
Good job.
It did it.
Make the logs bigger, maybe. Yeah. Maximize.
It's doing it. Now what you see is service exited and restarted the service because of the fact that, like we were talking about, it ran the code and a container has a defined life cycle. So it's killing it and restarting the container repeatedly, which is not necessarily ideal, but you can see that we are in fact getting our data. It's working. So let me see. Yeah. Hang on a minute. I just put my finger on. Let's put the camera back. Made it. Only took 14 extra minutes, but we did it. So we built a container from scratch, pushed it over to the Pi, and we're now containerized that same Python code running atop Balena OS as the host. Right, well, I'm a little off the camera there. Let's get that back in. And this was the SD card previously. Let's just see.
Trash it.
Oh my God, don't do that.
There we go.
Oh my God.
There.
That's violent. That's very violent.
Problem solved. There you go.
That's the only way to guarantee don't pick that sucker up again.
That's exactly how you know not to use that one again. We do kill SD cards around here. That card has probably been written hundreds of times. That is true. I'm going to push my luck. We don't need to stay on the live stream, but I'll save that. I'll come back to here. I'll redeploy. And I just want to see quickly if it grabs the delta. We should be able to see that the change of only one line generates just a very, very small
Delta.
Yeah, to the container. Let's just see what happens. I realize I'm pushing my luck here at this point, but I just want to see what happens.
Glutton.
David killed my SD card. Yeah, sure did. Killed that one. We don't want this one back. You know, it goes to show, I mean, that was a high quality one. That was a Kingston. Hold on, let me put the two halves together so I can read it. That was a Kingston 16 gig. So yeah, I probably have had it a while, right? So if you think about that, 16 gig, I mean, that's probably the smallest you could even buy now. So yeah, I've probably had it a while. It's a class 10, actually UFS or UHS. I can't remember what the U designation is, but a U1. So, you know, brand name, but it's, and a quick one, but the blocks on these things just wear out.
It had a good life, a lot of operating systems and containers.
Yeah, it had a lot of OSs and a lot of containers. It had a good life.
But it ended violently.
It ended violently. That's how you know not to use it again. Because otherwise, yeah, I would toss it back in the pile and then end up in the same situation in the future. All right, so hold on. Successfully uploaded the image. I just want to see. This might be a little difficult. Hold on. Can you make just the... Mark, can you zoom in a little tiny bit? But we can see that the delta size is 3.55 kilobytes. So this time we don't have to download. Oops.
Minimize. Not what?
Yeah, so it's updating, but we're not going to download 200 megs this time. We're only going to download 4 kilobytes. Now, on my 56K modem, that should take less than a second. And I think it's doing it right now. It downloaded it. It's starting it. And I see some... Okay, it's running. The data came back. Let me expand the logs again. You can see that it killed the previous container. It deleted the previous container, installed the new one, started up, and now it's in its quick and dirty loop without exiting. So my quick and dirty hack.
There you go.
Worked.
Beautiful,
all right.
David. That was a very good job.
Man, that was stressful. That was stressful. And we killed an SD card.
Great example
of SD card
of Delta.
It's in the heaven of SD card, don't worry.
I was going to say, great example of the Delta capability.
Yeah.
You know, where no need to push everything, just what changed.
Yeah. So,
all right.
You know,
with that, David, I think we should wrap it up.
Yeah, we better wrap it up. We are way over time, but we had fun. Let me bring my camera back on me. And the question is, where is my camera?
Literally kill it, yeah.
We can literally killed it. That is correct. All right. Well, with that said, I think we can close it out. Definitely, definitely, if you get a chance, we have 2 events coming up. We have PyCon India, doing a workshop there October 4th, I want to say. So check out the PyCon India site. We also have ARM Dev Summit coming up October 8th. So we'll be doing a workshop there. And as I said at the top of the stream, next week is our summit week. So we might not have a show, or we might have a total giant party. I'm not sure, but I will keep you updated. You got that. You got the box. You already opened yours too. You already dipped into the box. So
yeah, absolutely.
All right, guys. Let's close it out. Bye, everyone. Thanks.
Have a good weekend.
And sorry that it was a little stressful today.
Good job, David.
Good job, man.
Bye, everybody. Mark, you want to hit the end button? Close us out. All right. See ya.
Bye-bye.
Bye.